Hi, my name is Molly Till, and I am a 10th grader at the PA Distance Learning Charter School.
And I'm Josh Shaw. I'm a senior with PA Distance Learning Center. As Odyssey Fellows, our project is Life on a Wall. Through our works, we are investigating the connection between environmental science and community development, and to show how natural environments support human well-being and performance. To expand on our study of living walls, we are focused this year on phytoremediation. Phyto is the Greek word for plant. Phytoremediation is the use of plants to remediate the environment. That is to take out harmful contaminants and pollution from soil, water, and air. Today we're going to focus on the phytoremediation of soil. Specially selected or engineered plants are used in phytoremediation. The plants can contain the contaminant, they can absorb it, but then the plant is poison for bees and people to eat. Or the plants can render the contaminants harmless by metabolizing various molecules. Phytoremediation has a lot of great qualities. It is an energy efficient, it looks beautiful. You can use it with other traditional remedial methods as a finishing step to the remedial process. However, plants that have absorbed contaminants can disrupt poison entire ecosystems if eaten by animal or insects who either die or pass the contaminant up the food chain. These hazards can be minimized by carefully selecting the right species for the ecosystem and removing contaminated plants after they've done their job.
The EPA, which stands for our Environmental Project Agency, has cited many benefits to using phytoremediation. It takes advantage of natural plant processes and requires less equipment and labor than other methods since plants do most of the work. Also, the site can be cleaned up without digging up and hauling soil or pumping groundwater, which saves energy. Trees and smaller plants used in phytoremediation help control soil erosion, make a site more attractive, reduce noise, and improve surrounding air quality. Let's check out 3 ways that plants are used in the phytoremediation of soil. 1. Mineland reclamation. 2. Acid mine drainage remediation. And 3. Redeveloping an urban brownfield.
Our first story is of mineland reclamation from an article titled Reimagining a Sustainable Future for Mine-Scarred Lands. A group of faculty and students worked on reimagining the mine-scarred landscape of McDowell County in West Virginia. 600 acres had been decimated by mountain mining with valley fills. In mountaintop removal mining, layers of soil are removed to expose the mines. The excess rock and mining byproducts are relocated to nearby valleys called valley fills. The team recognized that the landscape can never be restored to its original condition. Historic hardwoods and the vegetation of the rock high walls would not be able to survive due to the lack of healthy topsoil. Dr. Peter Butler led the team proposing a strategy using phytoremediation to restore nutrients to the soil. An initial environmental assessment would assure the substrate could support vegetation. Based on their findings, they proposed to develop strategies for building nutrients in the soil by identifying crops with bare root that could spread aggressively and choosing a mix of trees, shrubs, and perennials to support longer-term ecological sustainability. Unfortunately, they were not able to implement the work that was proposed, but the idea still provides hope for ways phytoremediation may be useful to restore mountain mining lands.
Jeffrey Scusen is a professor of soil science in the Division of Plant and Soil Sciences. He has more than 35 years of experience in reclamation of disturbed lands and agriculture. His research program includes acid mine drainage control and treatment. Acid mine drainage, AMD, is one of mining's most serious threats to water and can be devastating to rivers, streams, and the ecosystem. AMD forms when water comes in contact with exposed rocks containing sulfur-bearing minerals that react with water and air. It forms sulfuric acid, dissolved Fe and Al, and other chemical elements. Active chemical treatment of AMD to remove metals and acidity is often an expensive long-term proposition. In recent years, a variety of passive treatment systems have been developed, including phytoremediation. There are two mechanisms in phytoremediation of contaminated mine sites. The first is phytoextraction, where plants extract heavy metals from the contained sites and store the extracted metals in their biomass. The second is phytostabilization.
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 Where plants are used to prevent erosion of heavily contained acid sulfate.
Our third story demonstrates how phytoremediation was used to redevelop an urban brownfield. Brownfields are areas of an urban landscape where factories or businesses have closed, and future use of that land for housing, parks, or new business is limited because of the environmental contamination. Steps must be taken to remediate it in order to rebuild on that land. In Pittsburgh, most of our riverfront developments, like PNC Park, Heinz Field, and Rivers Casino, sit on former brownfields. According to the Western PA Brownfield Center at Carnegie Mellon University, Southwestern PA has at least 26 brownfield sites in various stages of redevelopment. Currently in Pittsburgh's Hazelwood neighborhood, there is a former site of two successive steel manufacturing companies. It is the future home of Hazelwood Green, a 178-acre site for new technology companies and outdoor public spaces. Asbestos, petroleum, and polychlorinated biphenyl, PCB, on the grounds were mitigated through phytoremediation in order to prepare it for a new mixed-use development. Plants were used to contain, degrade, and eliminate pollutants.
We had no idea plants could be used to heal soil. We hope you learned as much as we did.
We can't wait to explore more possibilities. Please join us next time for Life on a Wall.